What's going on, guys? Welcome back. My name is Brandon. We've got a really fun episode today. This is going to be the last episode of the YesWelder MIG 250 Pro. We're going to be running some self-shielded flux core wire. Stick around. All right, welcome back, guys. Are you guys ready to do some self-shielded flux core wire? I know I am. Last week's episode, we ran some aluminum wire in this machine. I ended up showing you guys how to replace the liner, because whenever you weld with aluminum, you got to have a special liner so that the aluminum can feed through, because the aluminum is so much softer. So in that episode, I removed the liner, showed you how to set it up, and do all those other things. So if you want to check that out, go ahead and see that episode. There's a lot of good information in there. But for this week, we are going to be running some self-shielded flux core wire. So first thing I got to do is I got to pull this wire back onto the reel. Then I got to replace the liner inside this with a liner that's made for other metals, not aluminum. A little bit of a hassle, but again, guys, I bought this welder specifically to do aluminum. I suppose if you really wanted a quick changeover, one of the things that I would do if I didn't have any other welders and I only had this one, and I thought I was going to weld some aluminum occasionally and weld some other materials, you know, carbon steel occasionally, I would possibly buy another whip with that graphene liner already in it. So if you wanted to switch over from, you know, say a flux core wire or a solid wire to aluminum wire, it would literally just be a matter of unscrewing this like this and pulling the whip off your machine. It would be that easy. For our purposes, we're just going to replace the liner. One of the things that I like to do before I, pull this wire back through my liner is I like to trim off the end flush with a pair of cutters. That way, if there's any ball on the end of it, or there's some sort of foreign object, it's not going to drag back through your liner and scar up your liner. So it's just a good habit to get into. So now with that cut, now I can reel it back up onto the reel. So I'll just undo that and just spin her back. There it is. Preferably don't just not hold on to the wire. I was holding on to the camera. It can make a huge mess, so we'll try to get this out of here without it coming completely undone. There we go. Now with our wire out of there, we can take the whip off the machine. There we go. That leaves our liner exposed. Now we'll stretch this out and replace the liner. And replacing it is actually very simple once you have installed it the first time, because then you know what length to put it at. And then we'll pull this old liner out. There it is. And just coil it up so that you have it the next time. Here's the graphene liner I just took out of it. And this welder comes with this bag, so it's a good idea to keep at least your liners in it. That way they don't get filled up with junk from your workshop. So here's the liner that is for steel, in stainless steel, in flux core. Put the graphene liner back in there, and we are in business. We do reuse this nut. And it helps if you stretch this out across the workshop, guys, to make it a lot easier to feed through. Now if this gets stuck and won't feed anymore, just move the other end of the MIG gun around. It'll help feed it up into the gun. One of the issues I had, guys, was with this O-ring. This O-ring goes right here. It goes between the threaded piece and this piece of the liner that's movable. I just grabbed another one. I have an O-ring kit. You can get these are just cheap, inexpensive kits. You can get these at Harbor Freight. It doesn't have to be this big of a kit. And just grab one that looks remotely close and slam it on there. For ours, we'll just use one of these. Just a small little guy right there. Then I'll just stretch it on over. It doesn't help that I have fat fingers. Yeah, and I could probably foresee that these could fail easily. And that's all you gotta do, guys. That just keeps the dirt and crud out of the inside of that liner. I believe the gas goes through this one right here, not this one. Give it a little snug, doesn't have to be much, and that's plenty. There we go. And you can see that I keep parts and pieces inside this cabinet. So you could actually keep a couple of those spare O-rings, just throw them right in the cabinet. So if you're taking the welder somewhere, you have them with you. These pieces were also in the bottom of the welder. These are the pieces that we need to install for the rest of that liner installation. The next thing that goes in is this piece right here. And that just shoves through the front, through that hole right there. Just like that. So now this is the tricky part. We've got to put this little E-clip back onto that little notch right there. And the way I'm going to try to do this, guys, is I've got just a little magnet right here. It's a cheap magnet. It's a telescoping magnet. And I'm going to take that little E-clip, because I got massive fingers, so I can't really hold it. Now I'm going to put it on the end of that magnet just like that, and then try to slide it right on over that shaft. If you need more room, guys, too, you can also remove the drive wheel. That'll give you some more clearance. But by having this C-clip or E-clip on top of a magnet, it's going to keep you from dropping it down inside the cabinet over and over and over, because it can be a little tricky to get this on there. Holy smokes, guys, that was a lot of work. You can see I have it on there, that clip now, and I'll show you how I did it. I used that little magnet piece that I showed you. Then I took a little piece of paper towel so I could actually have both of my hands free, and I just wadded it up and jammed it right into here like this. And then I took this whip and threaded it back on, so that way it held that pin solid in place so it wouldn't rotate and spin around. That way it allowed me to use both hands to get on it. And then I just pushed that clip on using that magnet. It still wasn't easy. It took me about 15 minutes to get it on there, but the magnet kept it so that I didn't keep losing it off the end and having it fall down into the bottom of the cabinet. It made it a lot easier doing it that way. And then I just pulled out the paper towel, and now we can put the whip back on. Yeah, there's that. And now we've got a spring we got to put in, which just gets pushed into this. We also got to put in our drive rolls. So now the one that you're going to want for this is the knurled one, not the smooth one. The knurled one is for flux core self-shielded wires. 0.8, and you want to face that. So this one's 0.8, 0.9. So face the 0.8 inwards, because we are using 30 thousandths. Line that up with the keyway at the bottom. That's it. Now we can put on our flux core wire. I got a 2-pound spool of Hobart 30 thousandth self-shielded flux core wire, and this actually did a really good job in the head-to-head test that we did, where we laid out a bunch of different wires. I'll put a link to that episode up above, but yeah, this one did really well, and I've had a lot of you guys say that you really like the Hobart wire. It did not test out as good as the Lincoln, but it did pretty good. So let's see how it does in this machine here. Then we'll just trim off this little tail right here where it had that bend. And we'll just start feeding it into the liner. We'll put a little tension on this reel because we definitely don't want this unspooling. That would make a heck of a mess inside the cabinet. Yeah, just a slight amount of drag, that's good. Now we've got it pushed into our liner a little bit, so we'll drop our drive roll in place. I've taken out the contact tip and I've taken off the nozzle so it can freely flow right out the end. Snap it on, there we go. We'll go around to the faceplate in the front, and this is the wire jog button right up here. I've got the whip stretched out fairly straight, and we'll just hit this. And you'll see the numbers increase right here when I do that. That'll be the speed that it's feeding in at. Now just thread your contact tip back on. Just go hand tight and just do a little bit. That's it. You're just making a good electrical connection. You're not really trying to like tighten it down. Then take some nozzle gel And what this does is this keeps spatter from building up inside the MIG gun, because flux core wire is notorious for spatter. So that just keeps the inside of the MIG gun clean and spatter free. It makes it easy to clean up. What works really good is right after you've used this, and this is a little warm, then you just dunk the end of it in this, and it coats the inside of that with like a gel, and that gel keeps the spatter from sticking inside this nozzle. So this is Hobart stuff. It lasts a real long time, but yeah, I use this all the time for flux core. And then just throw your nozzle back on and you are in business. Some people, when they're using flux core wire, they don't like to have the nozzle on the end. They say you can just see better, and I kind of agree. I do it both ways. Your gas coverage comes out these holes in the gun. See these little holes right here? That's where your coverage gas would come out for your solid wire. The school of thought is that this nozzle protects those ports from getting plugged up with spatter, or getting arced out on the table or whatnot. They do make a plastic piece, at least for some of the welders. They make a plastic piece. I don't know if they do for this YesWelder brand, but they do make a plastic piece that does shield these gas ports, but still allows you to be able to see the contact tip. But for now, we're just going to keep it simple. I'm going to keep the nozzle on the MIG gun. That way it'll like I say, it'll protect the internals. Now with self-shielded wire, you don't run it on the same polarity that you run it with solid wire. And I'm going to share a tip with you right now so that you will never confuse it. You'll never have to look it up. You'll always know right off the top of your head what the polarity needs to be based on the wire you're running. So we're using flux core wire here. People generally tend to look at flux core as a negative. They'll say, well, I only have a flux core welder, and they want to work their way up to a welder that takes gas and solid MIG wire. Flux core welders are looked upon in a negative way, although they're not. So that means negative, DC electrode negative. We are using flux core, so we're going to go electrode negative. So your little stinger piece will go into the negative terminal. That means that your ground or your earth lead will go into positive. So people look at a MIG welder as positive, solid wire with gas, as a positive thing. So that'd be DC electrode positive. So it's just kind of an easy way to remember it. People frown on the flux core. They consider it a negative, so it's DC electrode negative. People are more favorable to a MIG welder with gas. So when you're using solid wire with gas, it's favorable, it's positive. No charge for that tip. All right, let's get this jewel dialed in and get it snapped on. It's kind of loud. I complain about that each time, that it's a loud welder. I wish it just had a fan that came on when it needed it, but it doesn't. Just talk real quick about what these modes are. So that is stick welding, that is TIG welding, that is manual mode, and manual MIG, synergic MIGs. And for material, that would be, we're using CO2 100% with ferrous metal, so which would be steel, carbon steel. C25 gas ferrous metals, or maybe we're welding some stainless steel with 100% argon, you'd select that. Flux core, 035. We're going to be using flux core, but we're going to be using 30,000s. Or aluminum, 100% argon. That's what we did in last week's episode. We're going to go over to our chart that came with the machine. You can see it's got things listed for CO2 mag, CO2, flux wire, C25 gas, or 100% argon. So we are going to go with flux wire, no gas. Our material thickness is going to be right around 3 millimeters, which is just about 1/8 of an inch. Now we look at our welding current amperage at 30 thousandths wire, and then we intersect that 3 millimeters, and it's saying we want to be at 160 amps. And 16.8 volts with a wire feed speed of 9. So let's set this for 16.8 volts because that's the material thickness that we're going to be using that it's saying it needs. So 16.8. Again, we're in manual mode. Select the voltage right there. It's at 23. We'll do 16.8. 8. Here we go. There's our speed. Bring it down to 9. So one of the first things I'm going to be looking at with this, guys, is how smooth this feeds out this MIG gun. That'll be one of the things in the bead appearance and making sure that our voltage settings are right, and just overall how this machine works in general using self-shielded flux core wire. We've already run solid wire through it, we've run aluminum wire through it, we've had super great luck. Now we're going to run some flux core. Let's get going. So it felt like I got to turn that up a little bit, guys. We'll scrape it after, but it seemed a little sputtery. I've got to dial it in just a little bit better. We're going to have to up the amperage just a little bit and maybe the wire feed speed some. Let's go like 17.5. And on our speed, let's go 9.5, see if that helps. Yep, that's it, guys. That ran really nice. Now with flux core wire, you drag just like you would with stick welding. If you end up pushing it, you can end up with slag inclusion. And you want to open your gap up a little bit more too when you're using flux core, holding right around close to 5/8. Wow, that's hot. I was like really pinning it, holding a stringer bead. All right, let's patch that in. I think the temperature's a little too hot, guys, so I'm going to go down to 16.5 and 11.5 on wire feed speed. Seems a little hot. I'll tell you what, guys, I'm really happy with this welder. Getting all the settings dialed in, just playing with things, messing around. I think I might have to pick up some 035 wire to see how they work, how this thing works on the synergic settings, but yeah, just playing around, just trying different things. Overall, guys, this is a super capable welder as far as I'm concerned. I have no complaints other than that little foolish E-clip that you have to put on to change out your liner. That thing is a pain, so I wish they could come up with something different for that, but other than that, that's really the only complaint I have about this machine. That changing the liner on this is a bit of a project. If you're in a hurry, it's going to take you some time, so that's the only drawback that I see with this machine. Other than that, I absolutely love it. I have zero problems with it. And that's all there is to it, guys. If you're wondering about any of the stuff that you see me using in this episode, I'll have links down below in the description. And as you can see, this YesWelder is a very capable welder for a multi-process welder that also does aluminum. I'm thoroughly impressed. If you're interested in this, I can personally recommend this as being really awesome. I'm totally impressed with how this thing works. If you use promo code Brandon Lund on the links down below, you're going to also save yourself some additional money. New videos every Friday, so be sure to like, comment, and subscribe. Until next week, guys, I will see you then. Take care, stay safe, see ya.